Another investment problem, so I'm going to again write or put down my little bank buildings again. $5,000 less is invested at 4%. So here we go, 4% and 3%. 5,000 less, so if the 3% gets X, the 4% gets X minus 5,000. And we are given a total interest of $675, and again we have that word total in there, which helps us with how we're going to write out our equation. 0.04 times X minus 5,000 plus 0.03x equals 675. Now I'm going to multiply through by 100 right off the bat here and put 2 zeros at the end after the 675. And let's do the distribution. 4 times x gives us 4x minus 4 times 5,000, that's 20,000, plus 0.03. Whoops, it's no longer 0.03, it's just 3x equals 67,500. Okay, combining like terms, we now have 4 plus 3, 7x minus 20,000 equals the 67,500. And adding 20,000 to each side, we have 7x equals 87,500. Dividing each side by 7 yields x is equal to 12,500. And then we've got 5,000 minus x, which we've labeled at the top of the problem. We will subtract from 5,000 and get, I wrote this down wrong, this should be x minus 5,000 is equal to $7,500. Now let's label what we've got. The 12,500 is going to be at the 3% investment, 3% interest rate, and the other part is going to be at the 4% interest rate. These motion problems that we're going to be doing, or distance rate time problems, are going to be a little bit different than those that you did back in section 1.2. Let's see what we've got. A plane flies from Atlanta to Los Angeles against the wind in 5 hours. Now when you're traveling against the wind is working against you. Whereas when you have a tailwind or working with the wind, it's actually going to give you an extra little boost. So we've really got two trips here. Now here we go. We're going to write distance equals rate times time. The distance between the two cities is 3,200. So for both legs of this journey, I'm going to put 3,200 on the left side of the equation. Now when you are traveling to Los Angeles against the wind, your rate is going to be r minus w, where r is the speed of the plane itself and w is the speed of the wind. For the other portion of the trip, you're going to have the wind at your tail, and so you will have r plus w. Now the first journey took 5 hours and the second journey took 4 hours. And there we have two equations with two variables which we can solve. Now we have a choice. We can do the distribution in each of these equations, or sometimes it's easier just to divide by the 5 and the 4 right off the bat so we can have our r plus w and r minus w lined up. And that's exactly what I'm going to do here. We're going to take this first equation, divide it by 5, and the second equation and divide it by 4. This will give us 640 is equal to r minus w, and 800 is equal to r plus w. And this problem is just primed and ready for us to add together and eliminate those w's. We will now have 1,440 is equal to 2r, and therefore r is equal to 720, and the units here would be kilometers per hour. Now it wants us to find the speed of the plane in still air as well as the wind speed. Now we know that the two add together to be 800, so subtracting off the 720, we can find out that 80 kilometers per hour will be the wind speed. So we have the speed of the plane and the speed of the wind solved in this problem.